So graphing linear systems today, and here it says graph the inequalities. These are inequalities because there's more than one of them. So this is a linear system, but it's not a system of equations. It's a system of inequalities. And I don't know why that happened, but I'm going to keep going. So this is the way, in my opinion, you should do this. Take these kind of as equation 1, equation 2, equation 3, and equation 4. And then graph them as if they were totally different problems. So I'm going to graph this first. It says here that y is greater than or equal to 0. So what I do is this. I say, well, where is y? Where is y equal to 0? And it's a really weird looking line because we think of y as height, but we want the height of the line to be 0. So where is the height of a line equal to 0? And the height of a line is equal to 0 at y equals 0, and that is the x-axis. Wow. So that's this line right here, isn't it? And it goes right over top of this. And that is the line y is equal to 0, isn't it? But we want y is greater than or equal to 0. So the line is equal to itself, so it stays the way it is. And then where are the heights? Y is height. Where is the height greater than 0? And it's all of these heights up here, isn't it? So we just shade. And some of you I've seen over the years will shade like gosh, like you work for Disney or something. Just some lines in this direction just to give us an idea where this thing is. And kind of looks like I planted grass. But anyway, okay, so I'm going to move on to the next equation. Now I have this one done, right? This is that, right? Now I'm going to go to this one. X is greater than or equal to 9. Well, what does that line look like? If x is, so I'm looking at this as if it's x is equal, as if x is equal to 9. X is equal to 9. Where is x equal to 9? So I'm like, okay, well, maybe this is the point, I don't know, 9, 0 right here, okay? If I have one more point, I could connect the 2 points and I'd have my line, wouldn't I? What about 9, 5 or 9, 20 or 9, negative 3? Because what I want you to see is this, that, shoot, can we move my point over a little bit? Right, here's that point, 9, 0, right? 9, 0. So it's this vertical line, isn't it? Why is that true? That x equals 9? Because it's true if this line was perfectly straight and pretty, that everywhere on here would be the point 9 something, 9 something, 9 something. So x would always be 9. But we know that what we want is when is x less than or equal to 9. So the line is when it's equal to, and where is it less than 9? Well, we're talking about x values. X values that are less than 9 are like 8, 5, 4, 3, 2, 0, negative number. So it's from here back here, isn't it? So hopefully you're getting a picture now. Now we can see where our two graphs so far intersect. And what we want to figure out is, do all 4 of the graphs intersect? So far we have this area as our solution. All right, so we took care of this one, and we took care of this one. We have them both graphed, don't we? Now let's graph this one right here. X plus y is less than 15. What I'm going to do here, if you don't mind, I'm just going to rearrange this a little bit, and I'm going to say, I'm going to solve for y here. So I would have y is less than 15 minus x. If you're wondering what I did, I added negative x to both sides. I added negative x here and negative x here. And x minus x is 0, and 15 minus x was 15 minus x, right? Okay. Now again, I'm always pretending a little bit, because first I want to know where that line is. So what I'm going to pretend just for a second is that, remind me to put this back to less than, but, right? Remember that I owe a less than over here. But where is this line? So how am I going to find that out? I'm just going to randomly choose some x values. So I'm going to choose, well, what number do you want me to choose? How about 5? So if x is 5, and I get to choose the x value, but if I choose the x value, I get whatever y goes with it. So I chose 5 as x, so I take out x, and I put in the 5 that I chose. So y equals 15 minus my x value, which is 10. So it gives me the point 510. So this is 9 something. So half of that about, and 10 is maybe up here. So this is the point 9, 10, right? Now I need another point to attach my line to connect to my line. So maybe I'll take another one. Maybe I'll take, how about 0? 0. So let's say x is 0. So I'll take that in and I'll do this again. So you know what? I said x was going to be 0. So if x is 0, what's y? 15 minus 0 is 15. So y is 15. choose any point any x value you want. Remember, you choose the x value, and then you have to plug that in and see what the y value that goes with it is. So I have the point 0, 15. 0, 15. So this is 9. Here's x is 0. 15 might be up here, right? And then I'm just going to connect the dots, and it says, oh, remember, oh, thanks, whoever that was that just said that, because I heard you, is less than. Is the line less than itself? And if it's not, then what you have to say is you have to show a broken line. It's just notation for how to do this, and it just looks like that, doesn't it? Right? And it says here that we want y is less than this thing. So when is the height less than this? And the height is less than it here, under it, right? So we do this. I wonder if you can see what the intersection of all three of the equations looks like so far, right? Lastly, we finally got to the last piece, so we'll do that in yellow. Somebody yelled at me one time because I used too many colors. I really felt bad for the guy. It's like, really? It's a sad little life if you're upset that I have yellow. I'm using yellow. So again, I'm going to do the same thing. I'm going to take this left-hand side out just for a second. I'm going to call it equal, and then how do I plot that? That's even easier, right? That's even easier because now y equals x. You choose an x value. You chose 3. That's weird. Okay, so I don't know why you chose 3, but you chose 3. So you chose 3. So you said x is 3. Well, if x is 3, take out x and put x in. If x is 3, then y is 3. Good job. So that's the point 3, 3. So that's the point, I guess 3, 3 right here. Okay? And then we need another point so we can connect the dots. And the point you wanted was the point, oh, sure, you can choose 0. If you're wondering, there's nobody here with me. I'm talking to you. You chose x is 0, so look, fine. X is 0, so plug in 0. We get the point 0, 0, don't we? So that's the second point. This is the point 3, 3 here. This is the point 0, 0. Now, what I'm hoping you're noticing is that this thing got really complicated looking, didn't it? And so does the line count? The line doesn't count, right? So the line doesn't count. So and what does it say we want? Oh, we're good, right? I remember to put this in here. This is less than. Y is less than. Well, where is y less than that? Right? Where is the height less than the line? Well, it's less than the line under the line. So we'd start crossing this way. And I'm really hoping that you can see that there's this place where the three functions met. And it's right here, isn't it? Can you see it? It's all crossed over here. It's all inside here, I think. All right? So, all right, I think we have a deal here, and we have an answer. So let me just remind you, because if you look at this thing now, what this turned into, it turned into a lot. So remember, take it one thing at a time. Don't think about the other equations. Just take care of this one. And then after you take care of that one, then take care of this one. And after you've done that whole thing, this one, and finally this one, and then you're going to get your whole picture, okay? All right, you guys, I'm really proud of you. Good work.